Measure the height of a few million people and chart every single result. Almost all of them fall into this exact shape. Flip a coin 100 times. You might expect something like heads, tails. But that is not what happens. The results clump, runs appear. So count the heads across many rounds of 100 flips. The counts themselves fall into a pattern, not random looking at all, a shape. 1801. An astronomer spots a new object between Mars and Jupiter, the dwarf planet Ceres. Then it vanishes behind the sun. Every observation of where it might reappear is slightly different. Telescopes drift, hands shake, the numbers disagree. A 24-year-old named Carl Friedrich Gauss does not try to find the one correct measurement. He asks a different question. How do errors themselves behave? He is not reaching for genius. He is doing the unglamorous work of an astronomer's assistant, measuring, remeasuring, and staring at how wrong each measurement was. Gauss plots the errors. Small mistakes happen constantly, big mistakes happen rarely, and they fall off symmetrically on both sides. The errors themselves form a curve, the same curve as the coin flips, the same curve as the heights. This is the turning point. Error is not noise to be ignored. Error has a shape, and that shape is predictable enough to calculate with. Using it, Gauss calculates where Ceres should reappear. Astronomers point their telescopes there. It is almost exactly where he said. Decades later, psychologists design IQ tests to score this way on purpose, average at the center, rarer scores fading out on each side. A Belgian statistician measures thousands of soldiers' chest sizes and heights. The same curve again. He starts calling it the average man. Today, every GPS satellite deals with tiny timing errors. Engineers model them with this exact curve to correct your location on a map. Your blood pressure, your cholesterol, your lab results. The normal range on your chart is this curve, built from millions of other people. Modern AI systems are literally seeded with this shape, random noise drawn from it, before the network ever learns a single thing. Pollsters surveying a few thousand voters rely on this same curve to say how far their estimate might be from the true result. Take millions of people, any country, any century. Their heights, their errors, their test scores, their measurements, pile them up, and they keep drawing the same curve. Not because someone designed it that way, because that is what happens when enough small, independent things add up. Nature is not perfectly ordered. It is not pure chaos either. Between those two extremes sits a pattern, and that pattern is exactly what makes it possible to do science at all. If topics like this, the hidden pattern behind randomness, are the kind of thing you enjoy thinking about, there is a subscribe button right here. And if you hit like, this video reaches someone who would genuinely enjoy it too. Turning point.